Assalamu alaikum. In the previous lesson from Physics 9702, we have covered 11.1 that is going to serve as the prerequisite for 11.2, in which we are going to learn more about a fundamental particle, specifically quarks. So let's get started. These are the learning objectives we'll be covering. Understand that quark is a fundamental particle. Fundamental particle is what's not made up of anything else and what cannot be broken down further. And then there are six flavors or types of quarks: up, down, strange, charm, top, and bottom. And then recall and use the charge of each flavor of quark and understand that its respective anti-quark. Like for up, we have anti-up, anti-down, anti-strange, anti-charm, anti-top, and anti-bottom. They have the exact opposite charge, and there are other properties of quarks as well, but we'll not be getting into them. Then recall that protons and neutrons, they are not fundamental particles, that is, they are made up of something. And describe protons and neutrons in terms of their quark composition, which of course gives us a hint that they are made up of quarks. Then understand that a hadron may be either a baryon, that is, it is made up of three quarks, or a meson, that is, made of one quark and antiquark. Then describe the changes to quark composition that takes place during beta negative and beta positive decay. And then recall that electrons and neutrinos, they are fundamental particles and they are called leptons. Starting with the understanding of quark. Initially, um, we had known that atoms are fundamental particles and molecules, matter, all of them are made up of atom. But then with the discovery within 19th century, it was obvious that atom is made up of electrons, orbiting electrons, and then within the nucleus we have protons and neutrons, and they are the fundamental particles. But while electron still remains as a fundamental particle, अभी तक की discoveries के हिसाब से might be the case that in future we'd get to know that electron is not a fundamental particle and it itself is made up of maybe कोई दूसरा particle, but it has been discovered that protons and neutrons are no longer fundamental particles. They are made up of a fundamental particle, that is quark. And quark has total of six types, and then unka anti counterpart. This table right here is enough to let us know to let us know everything about quark that we need to know for this learning objective. We have up quark, it is represented with a small u, and then its anti-particle we have u dash, that is called anti-up. Then we have down with D, charm with C, strange S, top T, bottom B, and for their entire quarks we have just a bar placed on the letter we are using. And then these types of quarks, they have their associated charges as well. When it comes to up quark, we have plus 2 by 3 times E, and this E is what we used to call a fundamental charge. Then for down, we have minus 1 by 3e. For charm, we again have plus, and top के लिए भी ऐसा ही है. So like up, charm and top, they have same charge. And इनके anti-quarks के पास भी value same है, but just charge opposite है, right? And then comes down, strange and bottom. They have charge for minus 1 by 3e. And then इनके जो anti-counterparts हैं हमारे पास, they have plus 1 by 3e. Now, why did we even have to study the charges these quarks hold? It is precisely because the examiner is asking you to justify in terms of quark composition that a proton has the charge that it has. Like proton has 1 E, that is 1 plus E. And the neutron has 0 charge. They are asking you to justify it using quark composition. So that is what we are going to do in a while. Now, the fundamental particles, they are the fundamental particles, they are broadly categorized into two categories. We have leptons and then we have hadrons. Remember, in the last video, I mentioned that there is a strong nuclear force that acts between protons and neutrons. That does not affect electrons. Now, how do we differentiate on a broader level between hadrons and leptons when it comes to your paper questions? All you have to know is leptons are the ones which do not experience a strong nuclear force. And hadrons on the other ones are the ones which is strong, which experience a strong nuclear force. And as soon as I said this, it should have been clear to you कि फिर protons और neutrons यकीनन hadrons में आते होंगे because we have agreed that they experience strong nuclear force. Leptons के लिए example में what do we have? We have electrons, we have neutrinos. They are leptons. They do not experience a strong nuclear force. They do experience weak force, however. Then these hadrons are further categorized into two categories. Now, hadrons, they do experience strong nuclear force, and while leptons, they are fundamental particles. When it comes to hadrons, we have baryons and then we have mesons. Baryons are the ones which are made up of 3 quarks, and mesons are the ones which are made up of 1 quark and 1 antiquark. Further to these categories, let's just exemplify them. For baryons, we have, as an example, we have proton and we have neutron. How so? Protons are made up of 2 up quarks and 1 down quark, while neutrons are made up of 1 up and 2 down quarks. Let's just justify that this is the case. चलें जी. What is the charge on proton? The charge on proton is +1, right? Let's see if this composition gives us +1 charge. If so, then we'd say that this shows that this is the correct composition for proton. We have just seen that up quark has a charge of +2/3e. So +2/3e for another up, and for a down had -1/3e, right? As per the table we had seen. Let's just add them. This becomes 4e minus 1e, which becomes 3e, and the 3 in denominator as well. And this gives us +1/e, which is nothing but the charge on proton. So yes, proton is a hadron, that is, उसमें भी it is a baryon. It is made up of 3 quarks, and वो कौन से 3 quarks है? It is 2 up and 1 down quark. That is precisely what the examiner is asking you. वो आपसे कह रहे हैं प्रोटॉन की composition बताएं मुझे, quark composition, and then आप मुझे उसके charges से justify करके बताएं कि yes, proton has +1e charge. Now, this again makes us establish the point that the fundamental charge is E, right? Quark has fraction of fundamental charge, but just so you know, an isolated quark has never been observed. You'd always see charge in the composition that is you'd see proton, you'd see neutron. It wouldn't be the case that we can have one single quark. Now let's do the same thing for neutron. We know that neutron does not have a charge, it has zero charge. Let's see. We are claiming that it is made up of one up and two down, right? So let's just see. One up has plus 2 by 3e, one down minus 1 by 3e, another down minus 1 by 3e. Simplify them, you get plus 2 minus 2, which becomes 0 by 3e, which is nothing but 0, which exactly is the charge on neutron. And here comes a reasoning or a statement question from your past paper question, which says when a proton gets converted into neutron, mention the change in quark composition. So now that we have known that proton had two up and one down and neutron had one up and two down. So we say came in the conversion from proton to neutron, one up quark is converted into down quark. तो जहां मैं पहले इक्वेशन ये लिख रही थी कि प्रोटॉन जब कन्वर्ट होता है तो हमारे पास न्यूट्रॉन एंड देन उसके साथ एक पॉजिटिव बीटा पार्टिकल आ जाता है एंड क्योंकि इट वाज पॉजिटिव तो साथ में हमारे पास एक न्यूट्रिनो भी इमिट हो रहा था एंड देन उसके साथ हमारे पास कुछ एनर्जी इमिट हो जाती थी. अब मैं लिख सकती हूँ कि एक अप क्वार्क कन्वर्ट होता है डाउन क्वार्क में एंड देन दिस इज द केस जब एक पॉजिटिव बीटा इमिट होता है एंड देन साथ में न्यूट्रिनो और एनर्जी इमिट होती है. इफ दे आस्क यू टू डिस्क्राइब द emission of beta positive or beta negative in terms of quark composition, that is what you are going to write. And I hope you'd be able to write the equation when it is vice versa, like when you have to mention that um, beta positive ke bajaye beta negative is being emitted from the nucleus. Try it yourself and let me know if you were able to do so. Meanwhile, let's move to leptons. Not leptons. In hadrons, we have so far seen baryons. Now let's just see leptons. Leptons may we said leptons are those hadrons, like these are the particles which experience a strong nuclear force, but they are not made up of three quarks. They are made up of one quark and one anti-quark, and it does not have to be the counter anti-quark, just so you know, and it would become more clear when we discuss an example from mesons as well. In mesons, we have pi mesons. They are made up of one up and one anti down. See, it does not have to be up and anti up, down and anti down. It can be any quark with any anti quark. So when it comes to pi mesons, we have up and anti down. And then iske alawa we have phi mesons as well, which are made up of strange and anti-strange quarks. Let's just have a look at it again. See, fundamental particles, two types. Hadrons are the ones which experience a strong nuclear force. Leptons are the ones which does not experience a strong nuclear force. However, they do experience weak force. Leptons में we have fundamental particles. We have electrons and then we have neutrino. या positron या anti-neutrino, right? On the other hand, hadrons जो कि strong nuclear force experience कर रहे हैं, it is further categorized into two categories. They are made up of quarks, right? Now, if they are made up of three quarks, they are categorized as baryons. The examples we have are proton and neutron. And if they are made up of one quark and one anti-quark, then they are labeled as mesons. An example, we have pi and phi mesons. Did we cover the learning objectives mentioned here? We have seen the flavors of quarks. Now we know that इनके ऊपर कौन सा charge मौजूद है. And yes, we have agreed upon that protons and neutrons, they are not fundamental particles. They are made up of quarks. And We have also seen that hadrons can either be baryons if they are made up of three quarks, or they'll be labeled mesons if they are made up of one quark and one antiquark. We have seen the changes to quark composition that takes place during beta negative and beta positive decay. We have seen, I think, beta positive decay, and I've given you beta negative. Yes, we have seen beta positive, and you do beta negative on your own. Then recall that electron and neutrinos, they are fundamental particles. They are called leptons. That's all. That's literally all there was from particle physics. We had covered 11.1 in the previous lesson. We have covered 11.2 here. In the next video, inshallah, we'll be solving a few past paper questions before moving towards waves and superposition. Till then, Allah Hafiz.